go. Afternoon, everyone. We'll kick things off in just a second. It's gonna be day 2 of learning cybersecurity. I'm using TryHackMe to get me started. Yesterday, just completed day 1. It's pretty fun. Learned quite a bit about cybersecurity in general, and then some of the content that it shared. I wasn't quite familiar with everything, so that was always refreshing. So going to pick up day 2 now. Not sure how long we will be together, but we're going to make sure that we at least get some good learning in no matter what. And I think day 2 looks like it's kicking things off with a video named Packets and Frames. We'll start by going over what packets and frames are. Well, maybe watch the video first, then do the reading, take the quiz, and keep moving. Hope everyone's doing well out there today. Almost ready to kick things off. If you're stopping by, let me know where you're stopping by from. Certainly want to tell you thank you. And just want to know where you're checking in from. It'd be nice to know. I was about to get things going in just a second. All right. Almost ready to get going. Hope everyone's having a fantastic day. No, I am. Things have been going pretty smooth. Excited to get some learning in, learn something new. Do a little bit of recap later on. And get ready to do it all over again tomorrow. All right, so let's kick it off. So as I mentioned, today's day 2 of learning cybersecurity. I'm using tryhackme.com to get going. I'm going to go through all of the content that's listed there. Be on the lookout for a daily update as a video upload. I'm going to start that once I'm done with the stream to do a recap of yesterday and then continue to go on from there. A little personal accountability, reinforcing some learning, and just want to be an inspiration to someone. More importantly, to show that if I can do it, you could do it as well too. So yesterday we kicked things off with the overall cybersecurity, and it placed me to do a networking introduction. So that was pretty cool. Now we have already kind of talked through how networks connect, what's involved, IP addresses, MAC addresses, the OSI model, all of that good stuff. Now it has transitioned into what are packets and frames. So that's what we're going to pick up from today. Packets and frames are a small piece of data that when forming together make a larger piece of information or message. However, there are two different things in the OSI model, okay? Packet is a piece of data layer from layer 3, the network of the OSI model, containing information such as the IP, header, and payload. A frame is used at layer 2, which is the data link of the OSI model, which emasculates the packet and adds additional information such as the IP address. So the packet itself is going to come from the network layer of the OSI model, which contains the information such as the IP and the header, which basically is the carrier, if you will. The frame itself uses layer 2, which is the data link of the OSI model, which is going to encapsulate, if I could talk today, the packet and add additional information to it, such as the MAC address, so that it can identify that data that's being sent. It's going to give it the MAC address as its identifier. You can think of a process as similar to mailing a letter through the post. The envelope is the frame, which is used to move the contents in the analogy of the packet of the envelope to another place. Once the recipient opens the envelope, which is the frame, they will know how to forward the letter, which is the packet itself. This process is called encapsulation, which we discussed in room 3, the OSI model at that stage. It's safe to assume that when we are talking about anything IP address, we're talking about packets, okay? So let's go ahead and make some notes of that. Packets and frames. So a packet, a piece of data from layer 3 network layer of the OSI model contains info such as an IP header and payload. A frame used in layer 2 data link of OSI encapsulate the packet and adds additional info such as the MAC address. Yep. The envelope is the frame, which is used to move the contents in this analogy, the packet of the envelope to another place. Once the recipient opens the envelope, the frame, they will know how to forward the letter, the packet to itself. This process is called encapsulation, which is discussed in room 3, the OSI model. At that stage, it's safe to assume that when we are talking about anything IP address, we're talking about packets. Yep. Efficient way of communicating data, access the network devices such as those explained in task 1. Because this data is exchanged in small pieces, there's less chance of bottlenecking occurring across the network than large messages being sent at once. Makes sense? We talked about that as it mentioned a little earlier on, so that makes total sense there. Okay. For example, when loading an image from a website, this image is not sent to your computer as a whole, but rather small pieces where it is reconstructed on your computer. Take the image below as an illustration of the process. The catch picture is divided into 3 packets where reconstructed. So I don't see it listed here, but if you recall, it basically stated that we'll send the cat over in multiple pieces. That process itself was called I need to go back through my notes, but I remember talking about that where one protocol is to send it over in smaller pieces. But the downside to that is that it doesn't care if all of those pieces are actually received. So potentially there could be information left out. But depending upon the size and what exactly you're sending, that might be a more efficient way to go about it. So I'm assuming that this is saying that this works in the exact same manner. So just want to make sure we have a good understanding of it. Let's continue with our example of the internet protocol, a packet using the protocol. We'll have a set of headers that contains additional pieces of information to that data that is being sent across a network. So some notable headers include time to live. This field is set as expiry timer for the packet to not clog up your network if it never manages to reach a host escape. Checksum, source address, destination address. Checksum, this field provides integrity checking for protocols such as TCP/IP. If any data is changed, the value will be different from what is expected and therefore corrupt. Source address, the address of the device that the packet is being sent from. Self-explanatory there. The source address is just asking or stating that, hey, this is the source address of where the packet is being sent from. So that's pretty straightforward. Destination address, the device's IP address the packet is being sent to, that the data knows where to travel next. So pertinent information, pretty self-explanatory, but just have to make sure you retain it. There's a name for a piece of data when it does have an IP address information. That should be a packet if I'm not mistaken. Well, before I bounce out, we'll give this video a run at least through packets. Yeah, see, it used, well, there's like little doggies right here. But God, now I'm tripping. Yep. going on, my brother? What's up, man? Just learning. Want to learn something new, so I'm jumping in part time here to learn a little bit of cybersecurity, man. How you doing? That's too funny. Yeah. Hey, I don't need you for that. Just wanted to make sure I didn't miss anything. So answering the questions. Let's go. This should be join this room. That's a packet. AET. And if it doesn't have one, it is a frame. Has IP. Doesn't have IP. Mm-mm-mm-mm-mm. The you talking about the website that I was making for my friend? Yeah. So interesting with that. So the type of files, if you're talking about, yeah, this is free. Yeah, this is free, man. But if you're talking about, have you completed? If you're talking about the website for my friend, I have. Where we're at right now is just kind of a crossroads of if it makes sense to go with Cloudflare or what storage bucket to hold the MP3 and the WAV files. They're fairly large, and for right now, it's suitable. But we realized pretty quickly that it's going to, as he adds more music, he needs more storage, and he needs to make sure he gets a return on his investment. So we're using it. He's using it as a good starting point with the understanding that, hey, as you continue to grow and as you add more, we're gonna have to pivot. Nah, but good question though, man. Yes, sir. TCP or transformation control protocol is short. No, so he's working on his good question, man. He's working on his domain, but as soon as as soon as he goes public with it and he has it changed over, I'm gonna share it. He's actually a fairly, I know you care more about the developer side of things, man, but he's actually a fairly popular guy. And I didn't realize the demand that he had until we kind of started looking at, because right now he's using BeatStars. I don't know if you're familiar with that website. Um, he's using BeatStars right now, and we didn't realize. I didn't realize the demand that he actually had. I thought I could get away with a regular old Vercel blob, but as I was doing some research and adding some things up, look, it wasn't cost efficient to go that route. So I think Cloudflare is a better approach. We're going to transition him to that. But the thing with that is that it does require a cost, and he just has to be ready to assume that cost. So he's in the process of getting his domain, and then making sure that he's ready to go in on that investment. And then once he does that, we off to the races. You should, man. You should. You learn as much as you can, man. You know, this stuff is fun, man. Once you can do enough to be dangerous in whatever it is that you were previously doing, man, yeah, absolutely, go learn something new. Ain't nothing like it, especially if you're learning something totally different. It's fun. I'm enjoying. I've always been a lifelong learner. I'm enjoying cybersecurity thus far. I know I'm early in, but to give me an understanding of what exactly, when you're doing certain things, what exactly is taking place, and what exactly are you designing your and architecting your website to protect from. I know this is a much bigger scope than just a website. This is just a segment of it, and a hacker can get into a segment of a segment of a segment, as I'm learning. But it's pretty cool to kind of understand that. Yeah, I saw that too, man. Apparently, they've hit a point where they're having to make some financial cutbacks and laying off 75% of their staff. From what it described, it seemed as if it's due to the innovation with AI and how people can now leverage that to be a more efficient approach at designing. So just got to kind of keep that in mind, man. But that's disappointing. I'm a big fan of Tailwind. Yeah, yeah. I I'm still okay with Next.js for what I use it for, but there's definitely been some concerning things that have come up here of late. The good thing is fortunate enough to know how to pivot if I need to build a Flask or a Django project or a Spring Boot project. It's not a problem, and they have adequate enough UI interfaces to where you could take care of a client with those stacks. And Python and Java aren't going anywhere, so it's all good. It's all good. But yeah, quite a bit going on in the tech space, man. Especially for those of us that enjoy React. Absolutely. Yeah, it's tough, man. Especially if you work or you do something other than being able to keep up with news. I try to keep up with it a little bit myself in the midst of everything else going on, man. But it could be pretty tough. I thought about sharing some quick news updates, but man, I figure everybody else is already kind of doing that. But maybe I could take a different angle because I don't always have time to listen to a 20-minute video about something that's going on. Maybe a 2 3 minute excerpt will be suffice. So maybe that's a better, more efficient approach for someone like you and I. Absolutely. Well, you're right, man. Those are older and dated languages, but shoot, man, companies still use them. They tried and true. They're efficient. They're good at what they're good at. So I mean, if it works for you, it works for you. But yeah, those are pretty dated, and you probably should look to learn something a little more modern, especially if you're doing something from scratch for someone. If you're going into an employer, they may already have that infrastructure in place, so you have no choice but to learn PHP or something like that. But if you're dealing or building something for someone from scratch, you may want to consider a different route. But they work as well too. Just depends on what the client needs and what works out the best economically. You can. It's more efficient. It works. Less less inside of your package.json, a more efficient experience. I haven't used Bun myself, but from everything I've read, it is pretty good. So who knows? Maybe I'll try that out next, but we'll see. I like to try to get good at stuff and until I stick with certain things, but I'm definitely inquisitive. So let me know how that works out for you. I may try it out myself to be honest with you. Absolutely. Yeah. Sounds like a solid stack to me, man. Sounds like a solid stack to me. And that's everything that you're pretty much already familiar with, so it's not a very steep learning curve. If you can learn those, you can pretty much pick up on some of the other things as long as you got a high level overview of the concepts. Absolutely. That's what's up, man. So what you been up to today, man? What you working on right now? I said, looks like you're trying to get caught up on stuff, man, in the tech world. There's been a lot going on. Nice. How do you like Spring Boot? What's your comfort level with it? What all have you built? And yeah, data structures and algorithms. Fun stuff. Fun stuff. I enjoyed coding in Java. It's my personal favorite, to be honest with you. I don't know, now that I have this computer, I might make me a Java project. It's been a while. Yeah, I felt like a better programmer. I felt like a programmer using Java over anything else. Having to kind of write everything out and stick to a certain structure. It was kind of, it worked for me, if you will. I'm not the one that likes so much flexibility with things, but to each his own. But I love Java. Just REST APIs for off, and we'll be learning to get connected to Razorpay or Stripe. Love it. Love it. Do you have any experience with Razorpay? I appreciate it, my brother. Thanks for stopping by as always, man. I sure will. Not much. Okay. But man, be in touch, man. I don't want to hold you up, man. I'm sure you got other things to do. But as always, thanks for stopping by. I appreciate it. All right. So next, let's hit TCP. And this is transmission control protocol. Woo! Yeah, it's definitely sleeping time, man. 2 o'clock in the morning. Why you up so late? What you been up doing? You just getting home? uh, this protocol is very similar to the OSI model that we have previously discussed. In three of this module, TCP protocol consists of 4 layers and is arguably just summarized version of OSI model. Bless you. So, 4 layers are application, transport, internet, network, interface. Very similar to how the OSI model works, this information is added to each layer. Oh yeah, family time is always important. That's good to hear, man. Making sure I get some family time in as well. What what did you watch? Anything I might be familiar with? Now, Suits is pretty entertaining. I liked it myself. I never finished it, but I watched a few episodes in the first series and thought it was really really good. I don't know why I never finished it, but I will go back to it. Man, for whatever reason, I couldn't get into Stranger Things either. Everyone talks about how good it is, and I believe it is. It's what season 4, season 5 at this point, but for whatever reason, it just doesn't hold my interest. But maybe it's me. Maybe I just have too much on my mind at the time and probably should just sit down and do it. But I have to give it a shot though. How'd you like Suits? There's some hardware, some model working information is added to each layer of the TCP model as the piece of data or packet traverses it. As you may recall, this process is known as encapsulation, where the reverse of the process is decapsulation. Okay. One defining feature of TCP is that it is connection based, which must establish a connection between both the client. Yes. Connection is must establish a connection between. Yeah, you're right. Watching the robot series, yeah, pretty brilliant guy, man. It do kind of make you want to be a hacker and kind of understand what that world looks like. That's why I'm doing this now because I've always been intrigued. I don't know if I have any intentions of pursuing a career. Who knows? I won't ever say ever, but it is pretty cool to see the possibilities and the understanding of networks and hacking and infrastructures that they have, man. It's very cool. Very, 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 very cool. Because of this, TCP guarantees any data sent will be received on the other end. The process is named three-way handshake, which something we'll come to discuss shortly. A table comparing the advantages and disadvantages of TCP are below. All right, brother. Appreciate you, man. Thanks as always. We'll catch up soon. Guarantees the integrity of the data, requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used and must be resent. So that's pretty good. That means that it is going to make sure that you get everything you're supposed to get, which is a good thing. Capable of synchronizing two devices to prevent others from being flooded with data in the wrong order. So it makes sure everything stays synchronized and through connecting multiple devices. So that's good, or two devices, I should say. Performs a lot more processes for reliability. So this the more reliable approach. Disadvantages: requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used, must be resent. So this could be cumbersome if you're trying to send an image or something large or something that doesn't flow through properly, then it's going to bottleneck and continue to be resent until it actually does go through. So that might be a good one. Ensures reliability. All or nothing will be sent through. The slow connection can bottleneck another device as the connection will be reversed on the other device the whole time. Yep, TCP is significantly slower than UDP because more work computing has to be done by the devices using the protocol. So it's going to be a little slower because more work computing has to be done. Obviously, with UDP, it doesn't care if you get the information a lot or not. It's just going to send it. If it gets it, great. If it doesn't get it, oh well, it doesn't care. But with TCP, it's going to make sure that you actually do get your data. Everything is sent through. If something is being sent out of order, it's going to restart the entire process. So certainly when you have something of more importance, TCP is a more efficient route to go. TCP packets contain various sections of information known as headers that are added for encapsulation. Let's explain some of the critical headers in the table below. So the headers are basically what's being sent or what's being transported through. And these are the different things that it's going to be looking for, almost like a package, if you will, of the item to make sure that it has the appropriate header. So the header, the source port, this value is port opened by the sender to send a TCP packet from. This value is chosen randomly out of ports 0 through 65535 that already aren't in use at the time. Okay. The destination port, which is going to be who we're sending it to. This value is the port number of the application or service is running on the remote host, the one receiving the data. For example, a web server running on port 80, unlike the source port, this value is not chosen random. So port 80 seems to be a designated port that's not randomly selected. So that seems to be one that's designated. So we'll keep that in mind. The source IP, this is the IP address of the device that is sending the packet. The source, the originator, makes sense. The destination IP, who is being sent to the IP address of the device of the packet that's destined for. Perfect. Sequence number, when a connection occurs, the first piece of data transmitted is given a random number. We'll explain this more in depth further on. Sequence number, connection occurs, the first piece of data transmitted is given a random number. Okay, so I have to keep that in mind. Acknowledgement number, after a piece of data has been given a sequence number, the number for the next piece of data will have the sequence number plus 1. Okay, so it's going to go into more depth. So it seems like that's the way to keep them married, with the sequence number and the acknowledgement number. The sequence number is randomly provided, and then the acknowledgement number is going to be plus 1, of that number. The checksum, this value is what gives the TCP integrity. A mathematical calculation is made where the output is remembered. When receiving the device performs the mathematical calculation, the data must be corrupt if the output is different from what was sent. The TCP integrity and mathematical calculation is made. Okay. Just making sure, keeping everything in checks and balances. The data, the header is where the data, this header is where the data, i.e. bytes of a file that is being transmitted, is stored. I'm probably end up capturing this, a flag. This header determines how the packet should be handled by either device during the handshake process. Specific flags will determine specific behaviors, which is what we'll continue on to explain below. Okay, so interesting stuff here. These are the headers, and it just kind of gives a breakdown definition of what to expect in a TCP packet, what information is required inside of the header, what to expect, and what should be included. And that is the source port, the destination port, the IP of the source and the destination, a sequence number, an acknowledgement number, the checksum to calculate that the output is remembered. When the receiving device performs the mathematical calculation, the data must be corrupt if the output is different from what was sent. So it's just checks and balances to make sure that it's inspecting to make sure that it is getting what it expects. The data, this is where this header is where the data, the bytes of the file that is being transmitted is stored. So this is what's important. And then the flag, this header determines how the packet should be handled by either device during the handshake process. Specific flags will determine specific behaviors, which is what we'll continue to explain below. Okay. So next we'll come to discuss the three-way handshake, the term given for the process used to establish a connection between two devices. The three-way handshake communicates using a few special messages. So these are the messages. So this is the code that they kind of talk in when they're doing their secret handshake to say, hey, I've arrived, and here's how we communicate. Step one, message SYN. A SYN message is an initial packet sent by a client during the handshake. This packet is used to initiate a connection and synchronize the two devices. So we'll start with the SYN message. This is going to connect the two coming from the client. A send ACK. This packet is sent by the receiving device, the server, to acknowledge the synchronization attempt from the client. So the ACK, the ACK is coming from the server saying, hey, client, you just sent the SYN message. Let's acknowledge it. Let's sync, and let's communicate from here. The ACK acknowledgement package can be used by either the client or server to acknowledge that a series of packages have been successfully received. So step three is it'll send another ACK message. I'm assuming this is another one because it appears as if the second one is in communication with the SYN, but there's going to be another one acknowledging that we received the merchandise, everything is good. Once a connection or we have a good connection, we trust you, we know who you are, we were expecting you, everything checks out. Then step four is the actual data, which is once a connection has been established, data such as bytes of a file is sent via the data message. So in this particular step, we're going to send the actual data once the SYN and the ACK have communicated and established a connection. The ACK sends a message that everything is okay, we can trust this person. Then in step four, we'll send the data. Step five, this packet is used to cleanly, properly close the connection after it's been complete. So once the handshake is taking place and everyone is happy and everyone is good to go, the FIN packet is going to clean everything up, close the connection after the transmission has been complete. And the RST packet, this packet abruptly ends all communication. This is the last resort and indicates that there are some problem during the process. For example, if the service or application is not working correctly or the system faults. So I'm assuming that that one shouldn't be used, or it may only be used in certain situations, but for the most part, it shouldn't be used. But let's start to capture some notes. This is quite a bit. I want to make sure that this is retained and it's something that I go over this handshake process, which makes a lot of sense, but just want to make sure that I am digesting it as I desire. So first, we'll go pros, guarantees. Yeah, the integrity of data. Performs a lot more processes for reliability. Processes for reliability. Let's update this, fix this. And then we'll also include two device sync from being flooded with data. Okay. And then we know the cons requires a reliable connection. Connection. All or nothing when sending data. TCP is slower than UDP due to more computing being done. Okay. And these headers. I wonder, you know what? I feel like there's probably a diagram for this, but I'm not sure. This is captured anyway. TCP header. We'll go source port, value of port, randomly from 0 to 65535. Destination port. Port number that an application or service is running on the remote host. Port number that app or server is running on local host. Not random. We know where to go. Then we have the source IP. IP address of device sending the packet. Destination IP. IP address of device that packet is destined for. Okay, and then we also have the sequence number. Q is sequence number. First piece of data transmitted. Given random number. Acknowledge number. Sequence number plus 1. Number plus 1. Checksum. Mathematical calculation made where the output is remembered. REMBERED. Data header where data goes. And then the flag determines how the packet should be handled by either device during handshake. Three-way handshake. All right, so for this one, a nice diagram there, but I'm going to write this one out to make sure I have a good understanding of it. Send message is the initial packet sent by client and handshake. Then you have the send packets sent by receiver. receiving device to acknowledge sync. That's right. Attempt from client. We have the ACK from client or server. Series of messages have successfully been sent. Data once connected, the message itself. Fin is used to cleanly and properly close the connection. After it has been complete, an RST abruptly ends all communication. Last resort. Cool. Any data sent is given a random number sequence and is reconstructed during this number and sequence and incremented by one. Both computers must agree on the same number sequence for data to be sent in the correct order. This order is agreed upon during 3 steps. Sync, which is the client, here's the initial sync number. Sync ACK server, here's my initial sync, the INS to synchronize with somewhere 5,000 and acknowledge your initial number sequence. And then the ACK itself is the client. Acknowledge your initial sync number of 5,000. Here's the data that my INS +1. Cool. So the device, the client is the sender. It'll start with 0. And client sender, if it initially starts with 1, and if the client sender starts with 2, it goes from there. So the final synchronous number, remember, just adds 1, adds 1, adds 1. TCP closing a connection. Let's quickly explain the process behind TCP closing a connection. First, TCP closes with a connection once the device has determined that the other device has successfully received all of the data. So TCP will close a connection once it's confirmed it has all the data. Because TCP reserves system resources on the device, it is the best practice to close TCP connection as soon as possible. To initiate the closure of TCP connection, the device will send a FIN, which is what we just learned, FIN, packet to the other device. Of course, with TCP, the other device will also have to acknowledge this packet. Let's show this process from Alice and Bob. So Alice is from the client sending a FIN to Bob. Bob sends back an ACK, then sends a FIN, and then Alice sends an ACK to confirm the closure. So we send a FIN to initiate the closure from the client to the server. Bob gets the FIN, he sends an ACK, it's done, it's over with. Then he sends a FIN back to Alice to make sure she closes it. She sends an ACK back. So let's make sure we're right. In the illustration, we can see that Alice has sent Bob a FIN packet. Because Bob received this, he will let Alice know that he received it and that he also wants to close the connection using FIN. Alice has heard Bob loud and clear and will let Bob know that she acknowledges this. What is the header in a TCP packet that ensures integrity of the data? I think it was. Extended checksum? No, that's not integrity. Or is it? TCP gives TCP integrity. Yeah, maybe I was right. Check some. Check some. Yeah, I was right. I'm tripping. Provide the order of a normal three-way handshake with each step separated by a comma. So we know that it is a send. Wait a minute. Provide the order of a three-way handshake. Yeah, I'm sure. Yeah, send. And you have a send act, right? And then an act. Send act. And then is it a act? There we go. Cool. So that was pretty cool. So let's see what the video, what information it shares about it. Yep. All right, so let's knock out this one. Help Allison Bob communicate by reassigning the TCP handshake in the correct order in the static lab. Attached to this task, enter the value of the flag given at the end. Okay, let's test this out. Let Alice and Bob communicate by reassembling the TCP handshake in the correct order in the static lab attached to this task. Enter the value of the flag given at the end of the conversation. Can you hear me? So we know we need to do a send act at this point. And then we'll do a act of okay, great. I think I might have bought something somewhere. Okay, good. Or maybe I didn't. THM TCP underscore chatter check. Whoop 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 whoop. That should be day one there. right, so now let's jump into UDP, the User Datagram Protocol. UDP is another protocol that is to communicate between devices. User Datagram Protocol. Like his brother TCP and UDP, it is stateless. Stateless. Doesn't require a constant connection. Okay. For example, the three-way handshake doesn't occur, nor is there a synchronization between the two devices. Recall some of the comparisons made about these two protocols in Bloom 3 OSI, namely UDP is used in situations where application can tolerate data being lost, such as a video stream or video chat, or in a sync, or in scenarios where unstable connection is not the end all. A table comparing the advantages of UDP is located below. Recall some of the comparisons made about the two protocols in Bloom, namely UDP is a situation. Okay, UDP is much faster than TCP. Okay, faster than TCP. UDP leads the application software to decide if there are any control over how quickly the packets are sent. So it relinquishes control, it appears. Doesn't require as much. What's going on, my brother? How you doing, man? Thank you. Sorry, I missed it, man. What's up, buddy? What's going on, my friend? I appreciate all the support. Genuinely do. UDP leads the application user software to decide if there's any control over how quick packets are sent. UDP does not reserve a continuous connection. Faster, no ongoing connection. Leaves application user software to decide if there is any control over how quickly packets are sent. Disadvantages of UDP: doesn't care if the data is received or not, so it's just like not TCP, but there's a UDI, I believe it is. Not as flexible to software developers in a sense. Doesn't care about data, not flexible. This means that unstable connections result in terrible experience for the user. So that's going to be pretty much standard, but I get it. As mentioned, no process takes place in setting up a connection between the two devices, meaning that there's no regard for whether or not data is received, and there are no safeguards such as those affected by TCP data integrity. So probably not the ideal method to send data if you have something that's of importance and you want to make sure that it is received whole. But if you just need to get it there and you don't mind rolling the dice, yeah, might not be a bad option for you. So the UDP packets are much simpler, and TCP packets have fewer headers. However, both protocols share some standard headers, which is what annotated, at the table below. Can't speak today. Time to live, TTL. This field sets an expiry timer for the packet so it doesn't clog up your network. If it never manages to reach a host or escape source address, the IP address of the device the packet is being sent from, destination, the destination IP address, pretty straightforward. Source port, this value is the same. Yep, destination port and data. So it is missing the source and data IP. It's missing quite a bit compared to TCP, but that would explain why it's not as secure and reliable in some respects, because it doesn't require as much. Next, we'll come on to discuss how the process of the connection via UDP differs from that of something such as TCP. We should recall that UDP is stateless, no acknowledgement is sent during the connection. The diagram below shows a normal UDP connection between Alice and Bob in real life. This would be between two devices. A request and response. Request from Bob sent to Alice. Alice sends a response. She sends another response, sends another response. Cool. What does user UDP stands for? User datagram protocol. This should be stateless. Stateless. Yep. What protocol would you use to transfer this file? What protocol would we use to transfer what file? I guess UDP. No, if it's a file, wouldn't it be TCP? Because you want to make sure everything gets there. What protocol would you use? The video call can be UDP, because you can have some leakage and be okay. So that makes sense. Cool. All right, so let's move on to ports 101. You already watched this? Let me watch this again. Mm-hmm. titled by their name. Ports are an essential point in which data can be exchanged. Think of it as a harbor. And port ships wishing to dock at the harbor will have to go to a port compatible with the dimensions and facilities located on the ship, and the ship lines up with the connect to the port at the harbor. Take, for instance, that a cruise liner cannot dock at a port made for a fishing vessel. Essential point in which data can be exchanged. These ports and ports that can park and where if it isn't compatible, it cannot park here. Makes sense. Networking devices also use ports to enforce strict rules when communicating with one another. When a connection has been established for calling from the OSI model room, any data sent or received by a device will be sent through these ports. And computing ports are numeric value from 0 to 65,535. Because ports can range anywhere between 0 and 65,535, that quickly runs the risk of losing track of what application is using what port. A busy harbor is chaos. Thankfully, with associate application software behaviors, with the standard of set rules, for example, by enforcing that any web browser data is sent over port 80. Software developers can design the web browsers such as Chrome or Firefox to interpret the data the same way as one another. This means that all web browsers now share one common rule. Data is sent over port 80. How the browsers look, feel, and easy to use is up to designer of the user decisions. Okay, so everything goes over port 80. While the port rule for web data is port 80, a few other protocols have been allocated a standard rule. Any port within 0 and 1024 is a common port. Let's explore some of those now. Okay. So port 21 is a file transfer protocol. This protocol is used by a file sharing application built on a client server model, meaning you can download files from a central location. Secure shell. This protocol is used to securely log into systems via text-based interface for management. HTTP, we all are pretty familiar with that. Hypertext transfer protocol powers the World Wide Web. Your browser uses this to download text, images, video files, and web pages. Yep, pretty familiar with that one. HTTPS, we're just adding secure, exact same as above, however, securely ensuring encryption. Server message block, SMG, this protocol is similar to the file transfer protocol, however, as well as files, SMB allows you to share devices like printers. Remote desktop protocol, RDP, this protocol is a secure means of logging into a system using visual desktop interface as opposed to a text-based limitations of a SSH protocol. We only have briefly covered the more common protocols in cybersecurity. You can find a table of the 1024 ports listed here for more information. Yeah, I will check that out. Wow. It's quite a bit of them. Yeah, it's a lot. What is worth noting here is that these protocols only follow the standards. You can administer applications that interact with the protocols on different ports other than what is the standard running web server 8080 instead of the standard 80 standard port. However, applications will presume that the standard is being followed, so you will have to provide a colon along with the port number. Practical challenge. Okay, now open the website. Connection. Open the site attached to this task and connect to the IP address. Okay. 8.8.8. And this is on port 1234. And this is THM underscore U connected underscore 2 underscore A underscore port. Cool. Hey, we got the correct answer. Let's check this out and see what it's talking about. Yep, pretty straightforward. Really ain't covered anything I didn't read there, but figured it wouldn't be a bad idea since they have it embedded in the lesson. Or maybe that's for those that prefer to listen and learn versus read and learn. I'm not sure, but I figure why not? port forwarding, firewalls, VPN, things I'm familiar with, but always good to get a nice refresher and maybe even learn a thing or two in it. That should be pretty cool. All right, so let's jump into port forwarding, which is an essential component in connecting the application and services to the internet. Without port forwarding, applications and services such as web servers are only available to devices within the same direct network. Take the network example below. Within the network, the server with the IP address 192.168.110 as a web server on port 80. Only the two computers on the network will be able to access this. This is known as the intranet. Well, if the administrator wanted the website to be accessible to the public using the internet, they would have to implement port forwarding like in the diagram below. With the design, Network 2 will now be able to access the web server running on Network 1 using the public IP address. It is easy to confuse port forwarding with the behaviors of a firewall, a technology we'll come on to discuss at a later time. However, at this stage, just understand that port forwarding opens specific ports needed to make websites accessible to the public. Port forwarding is configured at the router of the network. Choose the name of the device that is used to configure port forwarding. Isn't that a router? It should be a router. Firewalls. finish this one, because we're here now. And then next we'll do this. We'll just do everything it suggests. All right. The firewall is a device within a network responsible for determining what traffic is allowed to enter and exit. Every firewall is a border security for the network. An administrator can configure a firewall to permit or deny traffic from entering or exiting a network based on numerous factors, such as where the traffic is coming from. Where the traffic is going, has the firewall been told to accept or deny? What port is the traffic for? Has the firewall been told to accept or deny traffic destined for port 80 only? What protocol is the traffic using? Has the firewall been told to accept or deny traffic that is UDP, TCP, or both? Firewalls perform packet inspections to determine the answers to these questions. Firewalls come in all shapes and sizes, from dedicated pieces of hardware often found in large networks like businesses that can handle a magnitude of data, to residential routers like your home, or software such as Snort. Firewalls can be categorized into 2 to 5 categories. We'll cover the 2 primary categories of firewalls in the table below. Stateful. This type of firewall uses the entire information from the connection. The type of firewall uses the entire information from the connection rather than inspecting an individual packet. This firewall determines the behavior of the device based upon the entire connection. This firewall type consumes many resources in comparison to stateless firewalls, as the decision making is dynamic. Woo. For example, a firewall could allow the first parts of TCP handshake that would later fail. If the connection from a host is bad, it will block the entire device. Stateless. This firewall type uses a static set of rules to determine whether or not individual packets are acceptable or not. For example, a device sending a bad packet will not necessarily mean that the entire device is blocked. Whether or not individual packets acceptable. those mean? Whitelist these firewalls using fewer resources and alternatives that are much more dumber. For example, these firewalls are only effective if the rules that are defined within them. If a rule is not exactly matched, it is effectively useless. I didn't see it mention that. Hmm. 4 and 5. What? Network and transportation layer that I missed. I write it in? Hmm. 3 and 4. Well, why I got 4 and 5? I need to fix that. I don't know what I got. Get my notes listed differently. Oh, I see what I did. I went from bottom up. Never mind. I'm good. We're good with how it is. All right, let's go back to firewall. Malicious traffic. Deploy the static site attached to this task. Malicious traffic are marked as the packets in red. Legitimate traffic are marked as packets marked in red. The protocol you need to block this program to configure your firewall. Cool. Sorry, man. That thing was moving fast, but we got it. We got it right. So that's what matters. So VPN basics. Virtual private network. Technology that allows devices on separate networks to communicate securely by creating a dedicated path between each other over the internet, known as a tunnel. Devices connected with this tunnel form their own private network. Sweet. For example, only devices within the same network, such as within a business, can directly communicate. However, VPN allows two offices to be connected. Let's take the diagram below. Internet number one, office number one, number two, office two, three, two devices connected to the VPN. The devices connected on the network number three are still part of network number one and network number two, but also form together to create a private network number three that only devices that are connected via the VPN can communicate over. Okay, pretty straightforward. Let's cover some of the other basics offered by VPN in the table below. Allows networks in different geographical locations to be connected. A business with multiple offices will find VPNs beneficial, as it means that resources like servers, infrastructures can be accessed from another office. It offers privacy. VPN technology uses encryption to protect data. That means that it can only be understood between the devices it was being sent from and destined for, meaning the data isn't vulnerable to sniffing. This encryption is useful in places with public Wi-Fi where no encryption is provided by the network. You can use a VPN to protect your traffic from being viewed by others. Offers anonymity. Journalists and activists depend on VPNs to safely report on global issues in countries where freedom of speech is controlled. Usually, your traffic can be viewed by internet service provider and other intermediaries, and therefore track the level of anonymity the VPN provides is only as much as other devices on the network respect privacy based on the VPN that logs all your data histories essentially. TryHackMe uses a VPN to connect to your vulnerable machines without making them directly accessible on the internet. This means that you can securely interact with other machines, with our machines. Service providers such as ISPs don't think you're attacking another machine on the internet, which could be against the terms of service. The VPN provides security to TryHackMe as vulnerable machines cannot access using the internet. Okay, pretty straightforward there. VPN technology, PPP. It's not capable of reading that. PPTP, the point to tunnel protocol, is technology that allows the data from PPP to travel and leave the network. PPTP is very easy to set up and is supported by most devices. IPsec, Internet Protocol Security, decrypts data using the existing IP framework. IPsec is difficult to set up in comparison to alternatives. However, if successful, it boasts strong encryption and is also supported on many devices. Cool. It's PPP. The VPN technology uses the IP framework. VPN technology that uses the IP framework. Oh, IPsec. That was right in my face. IPSEC. successfully delivered. Routers operate at a layer 3 in the OSI model. They often feature interactive interface such as a website or a console that allows administrators to configure various rules such as port forwarding and firewalls. Dedicated devices do not perform the same functions as switches. We can see that computer A's network is connected to the network of computer B by two routers in the middle. The question is, what path will be taken? Different protocols will decide what path should be taken, but factors include path is the shortest, path is the most reliable, faster, medium, copper, or fiber. Switch, dedicated networking device responsible for providing a means of connecting to multiple devices. Switches can facilitate many devices from 3 to 63 using Ethernet. Switches operate at both layer 2 and 3 of the OSI model. However, these are exclusive in the sense that layer 2 switches cannot operate in layer 3. So you got to keep them with what they are intended for. Take, for example, layer 2 switch in the diagram below. The switches for forward frames. Remember that the original IP packets are encapsulated within the frame onto the connected devices using the MAC address. These switches are solely responsible for sending frames to the correct device. Let's take a look at the diagram of layer 3. Switch data layer 2 as they can perform some of the responsibilities of routing mainly. These switches will send frames to devices. Okay. A technology called virtual local area network allows specific devices within the network to be virtually split up. This split means that they can all benefit from things such as internet connection but are treated separately. This network separation provides security because it means that rules in place determine how specific devices communicate with each other. Makes sense. Route. What is the verb for the action? Oh, routing. Layer 2, layer 3. I put that in, right? Yeah. Okay, practical network simulator deploy. A static site attached to this task. An experiment with the network simulator. The simulator will break down every step a packet needs to get from point A to B. Try sending a TCP packet from computer 1 to computer 3 to reveal a flag. I always have to read these things about 5 or 6 times. It says from computer 1 to computer 3, a TCP packet. It didn't say anything about data. And this is the illustration of it showing the transmission. You can see it showing the handshakes here. Nice. Cool. We got it. THM U underscore got underscore data. Damn. How many handshakes? Ah, I missed that. Dang it. I closed out the darn site. I guess I better redo it. From 1 to 3 TCP send it. Oh, so it just shows 2. That should be the answer. Nope. So I counted 5 so far. Is it 5? That would be standard. Just thinking about it. I guess I probably would have knew that if I'd have thought about it versus worried about counting it, but it's all good. All right, so next should be how the web works. We may come back and crank that up a little later on. Pretty cool stuff.